First of all, starting what heads or which heads do you have here? Starting from right to left in this case, we have a B6 head, so a 1.6 ND MX5, which is pretty basic, so there's nothing really special about it, and it's a pretty common layout. And so here is what a 4-cylinder with a performance combustion chamber design looks like. Then we have a 4AFE, so this is the economic brother of the 4AGE. It has a little bit of a different layout and a little bit of a bit modern or more modern intake port layout, so this is going to be interesting for those that have a little bit of a newer car. And the combustion chamber is also a little different, though less likely to be found in a modern car. And on the far left we have a 1AT head. This one's already fully built and ported, but there are also some things that need to be looked out for, especially in this head, because this is also a 20 valve head. So we have a variety of heads here also. I obviously don't have a 3 or 2 valve head, but I guess for performance those aren't really that common anymore. And lastly we have a BMW M62, where the heads still are on the car, but I can still show you a few things that are interesting when it comes to especially this engine. So starting with this engine, this is the MX-5 engine, and I am filming this with my phone because I have a light on there so you can see much better into the ports. This is going to be just showing you the different layouts and what's the difference between them, or rather how different layouts contribute to differences in actual engine performance. So what we have here is a MX-5 head. You can see I already took out the valves, so we don't have any of those in there, but the angle of the port is, if we look from the side basically, is not very steep. It's relatively tame in comparison. We have a pretty good view of the valves, of the back of the valves, so that means that in theory you could say this head already would be performing pretty well, although there are a few things that might need improvement. First of all, what you have to consider is that air acts like a fluid basically. So if you have a like a fluid that actually has some sort of mass, which similar to water, air with a high speed or high velocity and also in a high volume has a lot of mass, and pieces that stick out or things that are rough or have edges in them, that really hinder the air from entering the combustion chamber at their highest velocity possible. So for example, if you look in here on the sides, you can see a little bit of casting flash right here. That's one thing that is not ideal. That's like basically the first thing that can be removed. So that casting flash in the middle there, we can find these on pretty much any head. Like in the middle here, it's even worse. On this head it's not particularly bad, I've seen much worse, but it is still something to you can remove, and this will actually do a lot because the rough edges are kind of a hindrance for the air. The next thing is this divider right here. So it really has a little bit of a relatively wide surface area, so the air going into the combustion chamber is going to be basically hitting that and slowing down a little. What you can do is thin that out to quite a lot, so basically as thin or rather as sharp as possible. Obviously you don't want to get it too thin, as you risk like removing material, or if there are like misfires into the intake manifold, which of course there shouldn't be, some pieces can break off, so you have to obviously consider that. But if you make that a little sharper, then that's the ideal basically scenario. That would be kind of the stage one you can do to this head. What a lot of people do, and what is not really the ideal way to do it, is they do gasket matching. So they put on an intake manifold gasket and match the port to the gasket. The problem with that comes that you need to also match the manifold, obviously, And the problem there is, well, if you have basically a wave in the channel where, because if you only match like the outer part here to the gasket and didn't expand the channel completely inward, then you have a wave in the intake channel that can actually slow the airflow down a little and basically hinder airflow. So gasket matching should only be done if, for example, the manifold has a difference, as in the material itself is a little bit different, so that you don't have a step in between both parts and the air can flow through smoothly. The problem is though, you have these studs or you have bolts or whatever, so there is always going to be a little bit of play in there. So there is always going to be a little bit of a step. So it would be a good idea to make the port of the intake manifold a little bit bigger, just slightly, so that this play there is in the manifold doesn't have a negative influence. In this case, we also have some cutouts for the injectors. That's not really an issue because the injectors sit in the intake manifold and they are designed to basically spray in this cutout, and then this is basically for better atomization because they can be moved closer to the intake valves. On the exhaust ports, this is basically the same thing. We have the divider, although you have to consider, obviously, in the exhaust port, the gases aren't going to come from where you are looking at right now, so they are not going to come from here. So that divider is not as important. You can still, however, make it a lot thinner because obviously then the exhaust gases have more room to exit. And here it's also not as important for flow, whereas in the intake manifold or intake side, you would be able to thin that out quite a lot. Here it's only for flow and not really for aerodynamics. We also, though, have some casting flash. You can't see it that well right now because there's a lot of carbon buildup right here, but we also have some casting flash, so that should be removed also. That's so much for basic head porting on this head. In one of the next videos, I'm going to show you how to do extended head porting. So like with expanding the exhaust runners or intake runners and expanding or also making the airflow better, which is not gonna improve it by as much as the first stage, basically, because you're also always gonna gain about 70 to 80% of flow in the first stages or first stage of this process, and the later ones are just gonna be tweaking. That is if you are using the engine close to stock, or for example doing a simple turbo conversion on a obviously high strung NA build. That's going to be a different story, but this is only showing you the basics for now. Next thing, we have for a FE head, and the first thing that comes to mind is we don't have those cutouts for the injectors anymore because these sit further back. But what also is interesting is that the angle of the port is much steeper than, for example, in the MX-5 engine. So this is common in more modern cars also. And you can see even more of the back of the valves. And the path for the air is much straighter than on the MX-5 engine. You can almost see the whole valve. And this is an advancement that has been going on in the last, let's say, 20 years, because that B6 engine or B6 head has been around for, I think, since the late 80s, so there's not much happened there. And this is from the late 90s, so already also pretty old, but since then actually not that much has been happening in the channel design for intake channels and exhaust. The manufacturers more so play around with combustion chambers, with camshaft designs, etc., intake manifolds, and so on and so forth. But as you can see here, there you can see that the design of if we look like from the front, you can see it goes much steeper down. And the design though is pretty similar, and you can basically do the same stuff as in the MX-5 engine. You also can see that we have a little bit more casting flash right here, and also in the middle there is quite a bit, and also the divider is a little bit thinner, but the same things apply you can do in the MX-5 engine. So using that to basically thin out the divider and remove the casting flash, that is the ideal thing you can do here for kind of a stage 1. As on the exhaust side of the 4AFE, there's a lot to do here because the port, as you can see, is very, very tight. There is quite a bit of material that can be removed left and right here if your exhaust manifold is the right size, for example, so you don't want a step. But as you can see here, there is basically a pretty hard corner for the gases they have to pass through, so you barely can see the valve, and also the middle part of the divider is relatively thick. So in this case there's a lot of room, or more room, for improvement on the exhaust side than on the intake side. This is a perfect port for a lot of widening, and actually will benefit from making the, or pushing the walls further left and right, especially because on the exhaust side it doesn't really matter as much if it is a little bit wider than in the intake side. Though if you make this larger by a bit, then this is going to be also hindering spool a little bit if you are running turbo, because the smaller the exhaust diameter is, obviously the higher the exhaust velocity or the speed of the exhaust gases is going to be, so they are going to spool your turbo quicker. While it may not have a huge effect, and also it will decrease top-end performance, you may desire better spool, but that is depending on your own setup. And this is why head porting is also kind of a thing to do that is always dependent on what you want to do with the engine and going to be wanting to achieve. And next we have our 1.8T head. This is a AGU head, so a stock big port head. There's two different head variants, so one big port, one small port. The thing is, a lot of people, although they are only running like 300 horsepower, say that the big port is the better choice, but actually the small port, if you're running anything below 500 horsepower and want better response or better spool, the small port is actually going to be the better option, because of the smaller ports, the velocity of the gases is going to be higher, and so the turbo is also going to spool higher, because they also have a different approach of getting the mixture ready for combustion. They use a swirl type head, so where the air is mixed a little bit better with the fuel, while the AEB or AGU is more relying on the head and the piston to make that happen, and it just does not work as well. And it has bigger ports, yes, but they are also only going to be relevant above like 500-600 horsepower. Below that you are not going to find any restriction in the small port head. Saying that, this is a fully ported head, so meaning this is going to be ready for 700-800 horsepower or even more. Although people have been running with setups like this even 1000 or more horsepower. As you can see, the dividers have been cut down quite a lot. This is a hand ported head, so nothing CNC machined, and this is what you can achieve basically with hand tools. And this head performed very well already on a dyno. I know because I got this head used, and I think this engine was making around 750 horsepower, but it was kind of a different approach because it was revved to about 10,000 RPM. So we have also a little bit of a widened port. So this is going to be a little different than a stock port. You might have to look out for, as you can see here, it is a little bit wider, has been port matched, but here also only in the beginning, though the transition is very smooth. I'm not really a fan of that, as I said before, but for example, some intake manifolds like CNC Innovations, they have already bigger ports stock if you buy them, and then you might need to adjust your head for that. and so you don't have a step in between those. So that might be what happened here, but it also has been widened left and right. There is a reason or a point where you actually need to stop, because in a lot of cases you have water channels right between here, so you can't go any further in or like down, because you're going to hit a water channel at some point. You can also see quite a lot of the valve right here. That is because the downward angle of the port, which is normally on a swirl head, that makes that is popular on a lot of cars that are more modern, or for example with the head of the Ford AFE that doesn't basically need that curve because it has it integrated, but the curve that goes like this into the combustion chamber is smoothed out here so that the air basically doesn't hit the other side of the port and has to be forced down. So it is basically still attached flow until it reaches the valve, although depends also on what RPM and what airflow, because at some point this is also still not going to work anymore. On the exhaust port we have a similar story, although as you can see here, as I said, you don't need it that much. The divider has been reduced by as much as possible. You can also not see it that well, maybe here it's better. The port has been widened a little bit, but also here we have that thing where the port closes off a little bit. That is because the manifold or the exhaust manifolds on the 180 are they have a relatively small diameter, and it just is like that on these engines. While yes, you could open up those ports more, they are in the diameter enough for what they're supposed to do, and they keep your spool still somewhat good even if you have a relatively large turbo. So while yes, you could increase the diameter and perhaps get a little bit less exhaust gas back pressure, therefore increasing your high RPM power, but if you want still some low-end spool, you should not really do that. As a last example, we have a BMW M62 right here, which is pretty interesting. It has huge intake ports, and what is also very interesting, look at the divider. It's already very, very thin. So as for performance or like high RPM power, this head is very good. As for design, we also almost have no casting flash, which is crazy good. So it's a very high quality casting, and yeah, this would be a close to ideal intake port. There's pieces of intake manifold gasket down there. I'll have to clean that out. I'll disassemble the engine anyway, but just to show you, this is what an optimal, basically for performance would look like. Optimal intake port would be, although it is a little bit oversized, you may not get the best spool possible with this sort of port. The exhaust side is similar to the other ones with a round design. A diameter is similar to the 180, which is interesting because this engine only makes like 230 to maximum 280 horsepower with the 4.4 liter. So I'm not sure why they went for such big ports and that design especially, but I guess BMW knew what they were doing, or they just didn't want anything changed. Maybe that was a design that they have left over. But as I said, the finish itself and the design itself is pretty good for high performance. So this is also probably one of the, if not the most important parts. This is the throat of the valves, or rather throat of the ports. And as you can see here, where it's kind of shiny and then goes to rough, that's where the valve seat was cut by the tool, and they cut a little bit into the port. And sometimes this edge is really, really rough or really, really harsh, and there's where a lot of performance can be had by making this edge smoother or smoothing it out completely. It's also possible to grind away basically the stem of the valve guide. The problem is you will have a less well supported valve, so it's not always recommended. So you maybe shouldn't do it if it's not absolutely necessary, but it will smooth out the flow in the port by a lot, because see, the valve guides are kind of in the way of flow in general. So a lot of high performance applications it is done. And then there's also the roof, which I talked about on the 180. So basically the curvature that goes right here, so that goes into the port. That is important that that is not too steep, as when it is too steep, in general we have laminar flow, or like flow, attached flow. So the air basically is kind of attached onto that curve, basically the same way as in an airplane. And if that curve, or if the flow gets too fast, or for example the volume of air moves too fast, or that angle is too steep, that curve is too steep, we are getting the flow is not attached, or will not be attached anymore, and therefore it will tend to be pushed to the other side of the intake port, and therefore obviously it will take up room and make the port less efficient, because the side of the valve, like this side, is not used or barely used anymore. And you will have a very low pressure or low speed area over here, and a very high speed or high pressure area over here, which you don't want. You want as smooth of a pressure gradient around the valve and in the port in general. That same thing goes for the exhaust flow, although it is reversed here. So here it is especially important with the guides, or for example with the steps in between, that these get smoothed out, like you can see here. I hope you can see that, like these areas where the valve guide is pressed in, that these are smoothed out a little bit, so that the air isn't hitting them as bad. You can see it better here. And also the, where I said where the valve seats are ground, that there are absolutely no edges. In this case it's pretty good, but for example on my 4A GE head it was pretty terrible. Moving on to the combustion chamber design itself, we have three very different combustion chambers across the board here. We have one that is very common in modern cars as well, so we have a plateau here, and otherwise it's a Pentrove chamber, and not much is going on otherwise. The things you can improve here are, for example, if you look on the valve seat, there are edges, like the transition from the seat to the combustion chamber itself. There is a little edge, and removing that, deshrouding the valves, what it's called, this will give you a massive improvement, because the air obviously flows attached to that corner also. And if it needs to do a big step to basically skip that little edge, that's gonna slow down the air by quite a lot. So removing this will probably give you the most improvement in the whole process of combustion chamber or even port design. We have those basically plateaus right here. Those are the quench areas. While there are people who remove them completely, I'm not a fan of that. Why is that? They are basically there to, if the piston comes up here, they are there to force the exhaust gases to the middle. So they are getting squished down here until the piston almost reaches it, and they are accelerated and pushed into the combustion chamber, and here also into the combustion chamber, to improve the mixture of the gas and fuel. So it's important to have them. Well, yes, if you remove them completely, you can run a lot more ignition timing before you experience any detonation, but you will lose a lot of bottom end power. If you're obviously looking for high-end power and are not looking for any low-end torque or whatever, you can remove them, as you will have less risk of detonation, and you will have less, or you have more room to improve your top end performance, but these are especially important for down low torque. You can smooth them out a little bit. So for example, there's kind of an edge right here. You can smooth that edge out so that that's a little bit smoother, because that edge can create hotspots and therefore knock, but it's not really 100% necessary, but it's something you can do on a chamber that has this design. Going on to the 4AFE here, it's a little bit different. While there's the same kind of step in between the valves, so deshrouding them also works here. All of the valves have a pretty much a squish or a quench chamber all around them, and that's to make the exhaust gas, even at low RPM, like 1500 RPM, to get this head to make a lot more torque than, for example, the MX-5 head. So this engine has a lot more torque down low because of this combustion chamber, because the gas or the air gets squished from every side into the combustion chamber, and in the combustion chamber it gets mixed really, really well, and therefore the mixture actually makes more power and the engine is more efficient because of the better mixing process in general. What you would do here, you can obviously remove these quench parts. What I would do, I would round those off here, maybe get that a little flatter so that it's like a transition, like so it's kind of only like this, and maybe remove that here completely because that's really not necessary, and make a little more room around the valves, because that air wants to go out of the intake chamber or out of the intake port in the combustion chamber, but because the valve sits so close to the wall right here, there's basically no room for the air to escape. So deshrouding, or rather expanding the combustion chamber around the valves, will help quite drastically here. On the 180, this is also a modified combustion chamber. I'll show you that right here because there a valve actually made contact and ripped off, so I'll show you this one too. And as you can see here, this is similar in some ways to the 4AFE, and similar but a little bit different. As you can see here, this part is much more open, so you don't have any shrouding around this valve, although you have still those squish areas right here. On the 180, these are kind of important because they make the mixture a lot better, especially this one right here in the exhaust part. That gives you a lot of torque. For example, if you look at the RS4 B5, which has the same combustion chamber itself, but the design is different because it has a basically round combustion chamber without any of these quench pads. The reason for that is because the engine has more torque down low because it has 2.7 liters and very small turbos, so it doesn't need them as much. And it's more oriented for performance because it's also from Cosworth, and they did some work on the head, so they removed that to get the engine to perform better on a higher RPM. Well, it's also possible, and what a lot of people do is they remove them completely, these quench pads. It also works and will deliver you more torque down low if you leave them and just round them off like they are here. They have been rounded off, in my opinion, not as well done as I would do personally, as I have not done this head, but they still are a little bit less than stock. And here also the valves have been a little bit more deshrouded than usual, but not that much. You can see here there's still some shrouding around the valves, which might be able to be removed. So this combustion chamber is almost close to stock, although the ports are very much modified. That's it from this video. I hope you enjoyed it. If you have any questions or anything you want to add, because obviously I don't know everything and I always like input from you guys, just let me know down in the comments below what you think could be done. Also, like, plus the things I mentioned, or what you would do differently, or whatever, or if you've done a head porting job that works exceptionally well and you found something that maybe works that I have not mentioned, would be pretty interesting. Otherwise, I wish you a nice day and goodbye.